Yeah, Jordan in there, he's trying to get all of it.
Okay, man, this damn thing's stuck down. Brad had the interesting idea of just putting this at an angle so we only looked at one of these boards.
That would probably be kind of... You mean the awesome to look at?
He said that the video quality was great. It was the audio quality that was crap, so he didn't care that if it was zoomed out enough to...
Wait, you just want to try to stick behind me?
That's what I did.
Hey, wait, you know, I'm not going to control the zoom from back here.
It covers a bit more area.
Well, that's the hope.
That's what I thought it would.
Oh, girls, with that close, see if I can actually hit using control now.
I don't think you can.
No, could you give it to...
But you have to face the front of it.
Right.
Fun for you.
Yeah.
Or just have, you know, somebody...
You get to tell her when she has to do it, so between the two of you, both of you, when it doesn't
Just have somebody like designated to stand in the
like
corner over there and just move it.
Alright, let's just talk about 222. You guys already did it, so we're not going to worry about that. But the point being is that for Anna's point of view, she's going by in the spaceship and the answer comes up as a negative number, so I already talked to them about that. What the heck does this mean? So when she's standing there, does that mean that from her point of view, that she's already seen this happen and she's telling Bob to, we draw this, she's headed this direction, and here's Bob right here. And this big explosion happens all the way over here, which that's awful. Explosion's up.
I can't see the explosion.
No, that's the reverse of what you want. Oh, no, 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 you never. Just got it. Well done, well done. Okay. So this explosion happens. Now, one of the things that we have to think about, we have to keep in mind whenever we're doing any of these problems, like in your test, etc., or any of the homeworks, is that when Bob says that something happens, it's not Bob waiting for the light to get here. So in other words, if it's 5 light years away, it's not like he's waiting 5 years or waiting 7 years if he thinks it happens 2 years in the future. Because if it happens in 2 years and then takes 5 years for the light to get to him, then in a total of 7 years. Which is a common way to think about this. That's not what's happening. Bob is communicating by Ansible. Finally came up with the name for that device yesterday. Alright. Are you guys familiar with the series Ender standard? We just had a movie that just came out recently. Okay. In that series, it's about a little boy who kills an entire civilization beyond us. Put it that way, it sounds very cliche, but it's actually pretty cool. I like it. So are the subsequent books. In that, they have this invention known as the Ansible, which allows them to talk instantly. It's basically a telephone across the galaxy, anywhere they want, not across the galaxy, across the universe, I should say. And they don't even entirely understand how it works. But the point being is that they found a way to bend space and time to carry your voice in sound wave, or your voice in light waves, such that it can instantly travel from one location to another. Because from light's point of view, light is everywhere at all time. It never takes any time for it to go anywhere. That was the result we found before. Remember, from the length contraction. From light's point of view, every place is instantly far away. Time contraction. Anyways, point being is, we have to treat it as though we can do that in all of our things in here. We're going to pretend that we've got the Ansible and pretend that we have information from all these locations. So Bob is talking to, I don't know, name him.
Junior.
Really? Just Bob Junior? Yeah, you just Junior. Oh, just Junior. Okay. Just Junior. Okay, Junior. Therefore, he must be short. Alright, so Junior's over here. And he's instantly talking to him, and he's saying that 2 years from now, he goes, oh, this happened. So it's 2 years on Bob's watch and Junior's watch, which are the same reference frame. So the same thing that's happening from her point of view, she's saying that, okay, she's got Amy that's sitting over here. Now, Amy can't just be sitting over here is the thing. Amy has to also be in a reference frame that is moving past this at the same point 8c, which I think it was. Isn't that how fast it was moving? The point 8c. So what we have to think about is Amy being in a reference frame that's identical to this, so presumably another spaceship that's also going by this at point 8c. So another important thing. Because they're all in the same reference frame. Alright, what does all this have to do with anything? Point being is that when she says, when you solve this, and it says that this happened 3 years ago, it's not saying that she's actually seen this and Bob hasn't seen this. Neither one of them have seen this. It's still going to take them a certain amount of time. As she's going this way, a certain amount of time for her to see the light get here. But by the time she sees the light, when she calculates it, she's going to say it happened X amount of time ago because the light took that long to get here. From her point of view, that must have been when she was way over here someplace in order for that had to have happened. So she's calculating that the explosion happened when she was back here. He's saying that it was 2 years ahead of time when she was up here. Does that make sense? That's where the negative number comes from. Okay? And this gets back to the idea where we have the spaceships, where we have the double clocks. So figures 216 and 217, where we said event 3, where the backs of the spacecraft line up. From Bob's point of view, that's where everything started. That was at time 0. And that was the first thing that happened, when the backs of the spacecraft line up. From Anna's point of view, that was the very last thing that happened. So it shifted. You just have a realization or something else happened? What's that?
Yeah, because you can think of the top as like, I understand this separation of Western frames better now.
Okay, good, good. Does that help at all with the negative numbers? Do you understand what I'm saying? Oh.
I kind of, well, actually, I Googled it.
I'm
I
so-
found out why, so.
Gotcha. All right.
Yeah, I tried Googling and the problem still doesn't make any sense.
Okay.
Actually, I think it makes less
It
sense.
depends on what you look at, because there was one, like, when you asked me answers, it was like, this dude is high, and then I found one from an actual professor, I was like, there you go.
Okay. If you find stuff like that, feel free to send it to me too. I know you guys are going to be Googling it anyway.
Well, I tried to ask about it.
Well,
and it didn't make sense.
unfortunately,
Does that?
unfortunately, some of these are on shade, and I don't feel like paying money, so.
See, I think what the dude who was high, I would have come in and asked about it so I could make sense of it, but then someone wasn't in his office.
When?
Today.
Was it my office hours?
He was your office hours today.
There aren't any, so no, I wasn't there. Nor am I going to be there.
So you were last time.
Convenient for you.
No, they come last time.
So, when are you guesstimating we're gonna have an exam in here?
Okay, based on this, we have probably another week and a half of chapter 2. So today being Tuesday, probably 2 weeks from today, would be my guess. Okay, we should be able to go through this. So we our first exam.
So can we look at this after class?
The exam is going to be just like practice problems.
Yeah, in fact, the exams will be easier than practice problems.
Really?
I like that.
They should be. Yeah, because you have to do it in an hour and 15 minutes.
I mean, outside of that one, the probably not hard.
Like, what was that?
Okay, everyone's
Number
gonna
4 and 5. I made a lot of
100%
sense.
helped it.
Wait, say this again?
No, actually, the 4th and 5th one we had to do.
You just had to do what about it?
Like, one of them, you got to start out with length subtraction and then plug into, yeah.
Yeah, what about it?
Like, they seem like
Yeah, I mean,
good.
Everything
I
but
understood those.
the ones we asked about yesterday
Yeah.
were good.
did we have
Good.
one from-
All right. Well, the idea being is, yeah, I don't want to.
No, he was
And then the last one is it you use 90 degrees for theta.
Wait, wait, theta?
The last part of the last one. Yes, 90 degrees for theta.
Because I was thinking,
Wait,
like, if you like look at
The
it,
last part of the last one when you're going around the circle.
Wait, I got a question without using theta.
I got the answer using 360.
I didn't even use
Which I
that.
guess.
So when this is going around like this direction, it is emitting from a 90-degree angle from wherever you are at, and it always stays at the 90-degree angle. So you should be able to do it just using a 90-degree
oh, I
angle.
thought like you like zoomed it in at a certain point because it takes like
Wasn't the answer
such a fraction of a second in a bit.
I don't remember this. Here you go.
Yeah, I got it without using theta in the last part, and I got the back of the book. I just used the ratio, and the ratio worked.
Oh.
Because I treated it as basically, since in terms of lights, the Earth isn't that big, you could basically just ignore the size of the Earth, and you ended up with the exact same answer.
That which makes sense that you're going to go to the size of the Earth. Packet's going around in a circle, so it's going to transition. No, stay. We'll worry about this later. I'll take a look at them. I still have to finish reading the other ones, and I'm hoping to grade this set and last set by Thursday. So there's some of the stuff that I want to talk about. There's a reason I didn't get to finish the other grading stuff, and we'll get to that today. Today is going to be an unusual class.
Unusual good or unusual bad?
Like
I don't know. I'll let you determine that.
So unusual bad.
Okay. All right, as far as the test goes, now, in the event that it is entirely an in-class test, that means that it will just be general simple problems using logic of, it'll just be length, contraction, time dilation, some simple stuff that you have to use. And what I'm going to be looking for is, can you pick the right numbers and put them in the right place in the equation? That's all I really want to know, because that means that you understand what goes where in the equations.
Do we have to memorize the equations, or?
No, I'll get the equations to you.
Like
So
on
you
the-
just you have to understand, for example, when we talk about events, what determines the event? What is the delta T naught, what is the T? You have to put it on the right side of the gamma. That's where the understanding of this stuff comes in, is being able to do that on the right side. Something like a spaceship problem with the stopwatches. That'd be a good one where I just have, I want to know 2 scenarios, what are the different times of the other clocks? You gotta rationalize. That's if, and I'm still anticipating this first test just being an in-class test. I don't see any reason why I can't necessarily do that. Unless I decide, there's a chance if I find a great problem that I want to do, that's a little bit bigger, it might be half the test in class, half the test out of class. I apologize, being that I've only taught this one at a time, and I don't know for sure what the test is going to look like. But I would be willing to bet on just being an in-class test for 2 weeks from
In the USO with practice? In the USO with practice?
Probably. Yeah, I don't see any reason for that. I don't know how valid it was. I'm sure I never gave a test on that. So, but yeah, let me look it up. And, I remember one of the questions on it. In fact, it was one of the questions was out of this book, and I wasn't using it. Yeah, let me take a look at that, and I'd be happy to do that. Okay. Back to that. All right. So, where did we leave off last time? Okay, a couple different things. I'm going to carry the book around as well, so not as detailed as I wanted to. He didn't. Fine, I'll just use the book. Alright, so last time we ended with this. Well, one of a couple things. So we did our velocity transformation equation. 1 minus ux v over c squared. Okay, we came up with a more general set of equations which didn't have subscripts x, y, and z, but we're going to want to use the ones that have x, y, and z because it depends on the coordinates that you're interested in. Okay. Now x we're always going to assume is aligned with the direction of motion. So that's the direction that we think we're going. Let's just make sure it's actually recording. Okay, so 1 minus ux v c squared. Yay, now we can go between velocity space. Alright, then the thing that we got into is we started talking about the momentum transfer. And we came up with this idea that in Newtonian logic, we can say that the total momentum as transferred from one coordinate system to the other is just the total momentum in the other coordinate system minus, pretend that's a summation sign, some sort of velocity times the integrated mass. Alright, so this is a constant. The mass is not changing, so we have the velocity times the mass. This is just some sort of constant. The point being is, as this goes up, this would have to go up by the exact same amount and down by the same amount. Momentum would necessarily have to be conserved, which is good. That's what we were hoping for. Then we tried to apply this to our relativistic equations with the new velocities that we saw. We found out stuff doesn't work. We're not going to get a relativistic version of momentum that allows momentum to be conserved. So instead, we had to come up with something else. And try as they might, they tried to come up with something that would give us this p total in one coordinate system, p total in another coordinate system, and just end up with some constant on the outside. Turned out that they couldn't do it. Okay, everybody who tried this, they always ended up with this constant was always a function of u and u prime. Okay, now what does that mean? What is the u and u prime?
Velocity of the two separate.
It's the velocity of the subject in its own range.
Right, so the problem being is as this went up or down due to the velocity of the individual particles within the reference frame of 2 balls, pool balls or something like that. So that means that over here, this is the velocity difference between the reference frames. This is changing every time these change. So if this went up and this went up, so did this. This went up and down, and all of a sudden our total momentum was not conserved. If we had a change in momentum of 5 over here, we'd see a change in momentum of 6 over here. It wasn't working, so we had a real problem with that. So it turned out that these things were linked. They were linked with something else. And to skip ahead, as the book does, this part is actually pretty trivial. They found out that, well, basically, all we have to do is we have to put another gamma factor in here for a definition of momentum. So we have yet a new gamma. All right, so gamma u. What is gamma u as opposed to gamma v? Nothing too surprising. This is awesome. I don't have to do that.
It's It's gonna be a little hard to read more than Brad.
What?
It'll be a little hard to read more than
You can zoom in.
Oh, you can zoom in. This is HD. So it's actually easy to see. He said very easy to see. It's just hard to hear.
According to that, that's a
So I wish I
Are you able to get some kind of mic to hook up with it? Like wireless?
I don't know.
You
I
can
could
remember those
walk
like
around.
headphones
Yeah.
Look on that
things.
little control thing. It says
Yeah, where my
like,
Call of
this-
Duty headset around here.
Yeah, I got a few of them.
Yeah, that'd be great. Alright, so the only difference between this gamma u and gamma v is gamma u now is a function of the velocity of the object within the coordinate system. So it is a little bit different. Alright, so then the idea becoming, now with this, we should be able to get a total momentum transfer. Now, doing so, oh, and one other thing that I want to note, this u vector here, as the book notes, is the velocity in all 3 dimensions. So we can't forget that. This is the vector u, so it has to constitute all 3 dimensions. Okay. Now, what ends up happening is, now if we want to show, if this is the relativistic version of momentum, we should be able to show that we can get a relativistic change in momentum from one coordinate system to another. So, what I mean, still on? A little more space. Alright, that P, on my momentum over here, prime, somehow I should be able to get to P plus something else over here. Now this other quantity over here, turns out that it doesn't necessarily have to be void of u, but it can be another quantity that is included. And what we're going to find out is that it's going to be energy. So, the conservation laws. Do you guys remember when we did the elastic collisions? You the only one that got to do the
the air track thing.
air tracks. You guys never got to play the air tracks, did you?
You
Showed
showed
up for like 2
them.
minutes, I think.
Oh, okay. So you got to play with the new air track systems we got. They're fun. I like them. Anyways, when we come up with the elastic equations, you guys might remember that we said that the velocity final for 2 is equal to like mass 1 minus mass 2 over mass 2 plus mass 1, and I think there's a 2 down here. To be honest, I don't even remember what the equations are. But the idea being is it was an amalgamation of both the conservation of momentum equation and the conservation of energy equation. In an elastic collision, you have a ball that's coming in, that's bouncing off another ball, instead of sticking with it, where you have all sorts of velocities and what's going on?
You were playing football.
Football.
I didn't know. Well, I just studied the space.
I'm a terrible human for this, but up at SMC yesterday or the day before, there was 2 kids playing football. One slightly has 8 more Cheetos in his life. The little kid had an arm though. Holy crap! The small little scrawny kid, he could throw perfect spirals, and probably as far as I could. I mean, this was impressive at standing this tall. So he would throw it, and then this fat kid would go and catch it, and I was sitting there waiting to turn right. So this is up on Waller. You turn right to go on to 20th or whatever it is. Right on top of SMC, right there by Eddie Weezy's. Anyways, the little kid would run, try to catch it, and it face plant hard. I mean, one of those face plants where his legs come up. He put down like this, and his legs are up in the air. Boy, it's the funniest thing to watch. I don't know. Well, maybe the ball didn't bounce back up, so it's down there underneath him or something. But I got to watch 2 or 3. It was only the one really good one, but he never did actually catch the ball. So that was really good. Legs up in the air. Anyway, this momentum. We want to be able to see this transfer. Okay. Now, we can show, in theory, that this transfer should occur like this. P total, okay, so our total momentum, which is the exact same thing we were trying to do over there, is equal to gamma v, okay, not gamma u, but gamma v, times P total, minus the velocity difference between the 2 coordinate systems, okay, and then we've got the summation of gamma u mi, and this is over I. Now all this basically means is there's no reason that we can't just sit there and write this as m total, this part here, because this is just the summation of these 2.
Again, that's just gamma v. There's no prime on that. That's just the board.
This is gamma v.
No, over.
Over here?
Yeah.
Yes.
There's.
So, the idea being is what we're trying to do is we're trying to convert from P prime total back to non-prime coordinate systems. And it turns out that the prime coordinate system
Okay.
is, oh, this is the board. Yes.
Okay. That's what I was asking.
Gotcha. That's the board. And the rest of this is how we do that. We have to get all the way over here. Now, there's this gamma v function, but it's more complicated than that because there's this whole other term, which is slightly like this, but different. Now, the book says this is now left for exercise 68, okay, to figure out how on the Earth we went from here, our momentum transfer. Now, momentum transfer is just mass, which is not relativistic in any way yet, and so we don't need to know how to move that. Multiplied by our u, and our u we don't even know how to move from one coordinate system to another. Okay, so we should be able to do this. Now, the problem is coming up with this equation, exercise 68. Here ends today's lecture. The reason being, this is an excellent lesson in the, I guess, fallibility of a new professor. I hit the brick wall of shame on trying to derive this equation myself for the past 2 hours. So, it has now become our collective homework assignment to figure this out. And I actually just about finished it before I got to class, but not long enough. What?
So you calculus guys have fun. I'm just kidding.
There's no calculus involved. It's just a lot of algebra. Okay, this is equation 223 on the bottom of page 35. And it's like the bane of my personal existence at this moment. So, for the rest of class, what I'd like to do is try to figure out where on earth this equation came from. Yeah,
Did you Google it?
yes, in fact, I can show you the answer that they give you, which is of no help whatsoever. Well, that isn't true. That's not of any help. It's not of enough help. Yeah, we got true.
Do you kiss your mother with this?
She doesn't know about this. I just showed her this one last time.
So we're just the entire class for. I'm gonna get paid.
Yeah, no, we're actually going to sit here and try to do this. I didn't know what else to do because about an hour ago when I was still working on this, or an hour and a half ago, I could either sit there and try and just skip over it, but I'm kind of like a dog with a bone, and I refuse to give it up. So I thought it might be a decent group assignment that we can sit there and try to do.
So you mean where
You could try to just let's go. That's what's an option.
You guys are welcome to leave. You can. I mean, this is now your homework assignment. Let's do it in 1 week. All I'm saying is that I struggle with this, so if you'd like to struggle with it on your own without me, then you're welcome to do
Well,
so.
in the class until it's all.
In other words, I'm going to stay.
So, because that wasn't your plan to begin with, when you came in? To stay here till 4:45?
So we're starting at.
Now, okay, so let's talk about that. Yes, I'm going to erase all this from the start. We're starting here. Okay, we're going to start with the idea. I'm going to rewrite everything that we need to know right now.
Wait, I think I get the answer to this.
It's not in the back of the book.
No, I got an idea.
Great, spin this back if you want to have an idea.
Dr. Ross?
Yeah, what do you got?
Is one of the assigned like exercises to derive this equation?
I'm sorry, what?
Is one of the questions in this thing to derive the equation?
Very specifically, if you read right above, it says the algebraic details leading to this question are followed are left to exercise 68. Fuck you, exercise 68. Yeah.
I'm going to Google.
Okay.
I will bring up, I actually have the answer guide for 68, which will help us.
Okay.
Like that much.
But you have the check answer that.
Which is identical to the, I have the publisher's answer guide.
Check better.
Okay.
Do they sell that
We'll
on
check
Amazon?
out if you like.
Nathan Hudson has check.
Full check.
Okay.
I don't have a paid membership anymore.
Okay.
You have a book from
You know, or David, we could actually try to do this ourselves. You know, that's an option.
Good students find the information.
Yeah. We don't. I
You're
tried to
doing
figure this out last
phenomenally on the
night.
test.
Hey, that's how I got through Physics 102.
Yeah. I tried to make this
You
out
guys
last
are
night.
encouraging me to make sure that we have an in-class test. Although I guess that's not really that bad. I always prefer an in-class test because it generally means it can't be terribly hard. You get a take-home test, at least when I was taking physics as a major, if I took a take-home test, it means it could be any level of hell. I mean, there was no limits to how bad that could be. At least in the in-class test. And plus, you could feel done. Like when you left, that was all you could do. As long as you had a take-home test, you never felt like it was always like that evil thing that was hiding under your bed. That still needed attention. All right. So, all right, what do we got here? So, we want to go from one coordinate system to the other in terms of momentum. That is our goal. So let's write everything down. Gamma u is equal to 1 over 1 minus u squared over c squared. All right. So we've also known that gamma v is equal to 1 over 1 minus e squared over c squared. Okay. So, if we read at the bottom of 35, it leads. Algebra details are left to the equation. Following equation are left for exercise 68. We're most interested in the result. Seeking, yeah, well, maybe you are. Seeking something analogous to the classical relationship of 221. So if we look back to 221, it was the equation that I had on it before. P prime total equals P total minus V times the summation of all masses. All right, if we apply the relativistic velocity transformation to 19, so if we go back to 219 and we look at the relativistic velocity transfer equation. Now, it turns out that they didn't actually mean 219, I'll figure this out. Instead, they really meant 220A, because we want this in terms of the x coordinates. It will be a little bit easier to think of it this way. I suppose we could do it either way. Yeah, we'll do it. All right, let's show this 219. U prime is equal to U minus V over 1 minus UV over C squared. Okay, so we can plot this in for over here, what we have. And we can then still massage it around. Nevertheless, somehow, magically, the end result of this involves gamma V. So this is where we're starting. We're starting over here, and somehow we're...
Well, 220-B and 220-C both have gamma V in them.
Say again?
220-B and 220-C both have gamma V in the equation.
Do, but this is for specifically things that are still on axis, and that's the problem. We're not talking about UX or UY. As far as I understand, it is possible that maybe I am not fully understanding that and I am missing something. Now, if we back up from 219 all the way up to it doesn't have any numbers, so I guess a little bit farther up than 219. Wait, maybe we can go. There we go. Page 31. Maybe we can use some part of the derivative of this to figure this out. But I'm not entirely sure.
Is there a chance the movie just screwed up somewhere?
I don't know. I doubt it. It didn't screw
Do they
up.
do this in another book?
Did they do this in another book? Quite possible.
I mean, don't you have another book for this class?
I do. If you like, I can go get it, and that can be.
I mean, I just want to know if they're setting it up the same way as this book is. That could be a problem.
Not likely. I mean, usually these things are written relatively differently from what's used for advanced books. But it's always possible, and I'd be happy to go get that. We can use any resources we want. But we gotta go from here to here, insert magic, and get this. Okay, that is our ultimate goal. And I've got about 3 or 4 pages over here of algebra trying to figure that out. So we can begin. So if you guys want, we can either work on the board or we can work just here at the table. It doesn't matter to me. Or you guys can work on your own and you can check things by me and I'll show you things that I figured out.
Seeing that you haven't got it, I'll stick with you with you route.
What did you say?
Seeing that you still don't got it, I'll stick with you with you route.
No. Oh, it doesn't matter. So I'm going to just try some random stuff on the board and see what we get. This stuff that I tried before. Okay, so. This has to be gamma U prime, by the way. You guys know that. Because whenever we do these also have to have prime coordinates on them. Hey, you don't have to hide that one. Just working is fine. You can hide it. It's actually really shitty at hiding it anyway.
Me? If I wanted to hide it, I can.
Yes, I look at anything here. So no one sells a paycheck or ships us out the window. Unless you would get a couple like $15.
Wait, what?
Unless you would a couple like $15 for an answer.
No, I do have a pet peeve about this, so, you guys probably know, you guys know me well enough to know that I'm, kind of like Apple. So I ordered the iPhone at 3 o'clock in the morning last Friday, and they've lost my order. well, you can just reorder it. I'm like, okay. And they're like, well, it's shipping in November. You guys, I heard this at 3 o'clock in the morning, so we'd be here this Friday. They're not helping me out a whole lot, so I get to go. I've been advanced 2 levels of service on AT&T, so I get to go bitch to someone else a little bit later. Good times, good times. So I have the printout of, actually,
Which one did you order?
yeah, I have my order confirmation in hand with the number on it, and I can't forget times. Class over.
Okay, Brad.
Kind of.
You gonna stay in class?
I'm done with eating chicken also.
Why? You hurt yourself? What, last night? Oh, that's funny.
Okay, throw it in this one.
You can
Maybe
leave
we should
class,
buy
or you
pre-cooked
can
chicken.
class to do it.
Oh, this is my
Right.
fault. Last
You
night.
think you can get
last
grilled
night-
chicken?
Yeah, the
That was-
chicken.
Oh, we did. I had chicken. He had. I didn't find. Yeah.
He's not kidding. It's
No,
okay.
that's not allowed.
This is- He's been 2 hours on this.
trust.
It's not necessarily that impressive. It's quite likely that I just missed things. All right, so MU prime. This is one of the equations. So we started off. We ended last time with the idea that the momentum transfer. I don't mind catching you up. Fact, but I didn't stop the recording.
Wait, so class